Section 4.7. In this section, we will find the slope of a line. We will determine the slope of vertical and horizontal lines. We will graph a line using the slope and y-intercept, and we will graph a line using the slope and a point on the line. The graphs of y equals 3x plus 2 and y equals 2/3 x plus 2 are shown at the bottom. Each graph crosses the y-axis at the point 0, 2, but the graphs have different slants. The slope of a line is a measure of the slant or the steepness of the line. The symbol for slope is the letter m. The slope of a line containing 2 points is the ratio of the change in the y values of the 2 points to the change in the x values of the 2 points. Slope equals m is equal to change in y divided by change in x. Oops. Just wanted to write that as sometimes you'll see it like this. Some of you may have seen that before. Okay? Now on the next page you'll see this slope formula. That's the one you'll get used. This is the one we're going to use to determine the slope of a line that goes through 2 points of the line. So that's what we'll practice now. Alright, if a line has a positive slope, it will go uphill from left to right. If a line has a negative slope, it will go downhill from left to right. A line that has a 0 slope is horizontal. A line that is vertical has an undefined slope. We'll talk more about that shortly. Find the slope of the line passing through the points -2, 0, and 4, 5. So I'll call this one x1, y1, and this x2, y2. So your slope m is going to equal y2 minus y1 divided by x2 minus x1. So that's going to be 5 minus 0 divided by 4 minus -2. So that gives you 5 over 6. So the slope of that line is 5/6. Let's practice a couple more. Find the slope of the line containing the given points. Just going to rewrite the slope formula. I like to do that whenever I'm using a formula. I like to write the formula first. So I'm going to have 4 minus 2 divided by 3 minus 4. This equals 2 over -1, which equals -2. That would be the slope of the line. And also by rewriting the formula over and over, helps you to remember it. -1 minus 4 divided by 4 minus 2 equals -5 halves. So that line would have a slope of -5 halves. Alright, let's go ahead and graph this line first. So if I plot these 2 points, the first point I would go right 4 and down 2. And the next one I'd go right 3 and down 2. So if I draw a line through those 2 points, that would be a horizontal line. Now let's calculate the slope of that line. So that's going to be -2 minus -2 divided by 3 minus 4, which is going to equal 0 divided by negative 1, which equals 0. So this line has a slope equal to 0. A horizontal line will always have a slope equal to 0. Notice if you look back at your points, your y-coordinates were the same. Okay, and when your y-coordinates are the same, you will have a horizontal line. So a horizontal line will have a slope of 0. Let's look at this next example. Let's plot these 2 points. My first point, right 3 down negative 4. My next point, right 3 up to 5. This creates a vertical line. Now let's find the slope of this vertical line. So I will have 5 minus negative 4 over 3 minus 3. Well, that will equal 9 divided by 0. And as you may recall, division by 0, or when you have 0 on your denominator, it is undefined. Division by 0 is undefined. So a vertical line, or notice in this case when your x's are the same on your 2 points, a vertical line has an undefined slope. Not 0, but undefined. The equation y equals mx plus b is called the slope-intercept form of a straight line. The slope of the line is m, the coefficient of x. So the coefficient of x, this m here, that's the slope of the line. And then this b, that's going to be where it crosses the y-axis, your y-intercept. So using your y-intercept and your slope, you can use those to graph your line. So that's what we're going to do now. So, in order to graph a line using the slope and y-intercept, the first thing you need to do is make sure that your line is in the form y equals mx plus b. So you have to make sure it's in this form. The first thing we will do is plot the y-intercept, b, as a point on the y-axis. And then we'll use our slope, m, to plot at least one additional point starting from the point that we plotted in step 2, or starting from the point or from the y-intercept. Okay? Now, when we use our slope, rise over run, remember our rise is up or down. A positive rise is up, a negative rise is down. When we're running, a positive run is right, a negative run is left. So if we're going to graph y equals negative 3/4 x minus 2, our y-intercept is negative 2. Our slope, negative 3/4. That negative can be with the numerator, or if we want, we can have it with the denominator. So I'll do a point in either direction. First I'll use this with, so that would be a negative 3 rise, which would take me down 1, 2, 3, and then run for positive 1, 2, 3, 4. That would be a point right here. Now let me go back to the negative 2, and now I'll use this. That's a positive 3 rise, 1, 2, 3, run negative 4, 1, 2, 3, 4. That's a point right here. Now WebAssign may only want one additional point, but you can see you can get points in either direction from the y-intercept. Graph by using the slope and the y-intercept. Y-intercept is equal to positive 1. Slope, rise over run, is 3 over 1, or we could use negative 3 over negative 1, just letting you know that. So I'm going to rise 3, run 1, Now if I rise 3 and run 1 again, it'll take me off the graph. So let me just get a point back in the opposite direction. That would be a rise -3 taking me 3 down, and then run -1 taking me 1 left. I could do it again. Rise 3 down, -3 down, 1 left, if you want to see more points on that line. Y-intercept equal to -3. Slope, rise over run. We can use -3/4, or we can use 3/4. So I'm going to use this one right here. I'm going to rise 3, 1, 2, 3, run -4, 1, 2, 3, 4. So I just used my y-intercept and then plotted one additional point. Rise 3, run -4. Now in this example, y equals -2/3 x. Notice plus 0, you have a y-intercept of 0. So that just means my point goes through the origin. So that's where we're starting. Slope, we can either use -2/3, or we can use 2/3. Okay. So I'm going to use this one to start with. I'm going to rise 2, run -3, and I may as well use this one once also. Rise -2, run 3. Good enough? Now in this example, it's not in slope-intercept form, so the first thing we need to do is solve for y. So I'm going to subtract 3x from both sides. That will give me -4y equals -3x plus 12. And then I need to divide each of these by -4. So I will have y equals 3/4 x minus 3. So your y-intercept is -3. Your slope, rise over run, equals 3/4. So I'm going to plot my y-intercept there. I'm going to rise 3 and run 4. 1, 2, 3, 4. That's good enough. Rise 3, run 4. I believe my next example is similar to this. Once again, it's not in slope-intercept form, so I need to solve for y. I will subtract 4x from both sides. Divide everything by -5. Y equals 4/5 x minus 4. Y-intercept in -4, slope, rise over run, equals 4/5. Plot your y-intercept at -4. I'm going to run 4, 1, 2, 3, or rise 4, 1, 2, 3, 4, and run 5. 1, 2, 3, 4, 5. Just enough room to stay on my grid. Great. Okay. The next couple of problems, we're going to be graphing a line using the slope and a point on the line. This isn't bad at all. And here are the directions for it here. It's pretty easy. Okay. So the first thing you have to do is they give you a point. So plot the point. So in this example, J, they give you the point -2, -3. So that's left -2 and down to -3 right here. And then you just use your slope, which is rise. Oh dear. I don't know what happened there. Let me get my eraser. Boy. 2 over 1. So my point was -2, -3. And then I can just rise 2, run 1. And that's it. I don't know that you'll need any more points. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. I'm just doing additional points so you can see the nice line that forms. Plot the point 4, -1. Write 4, 1, 2, 3, 4 down to -1. Slope. Now I'm going to want to run negative. So I'm going to put my negative with the 2. So I'm going to rise 1, run -2. Rise 1, run -2. Rise 1, run -2. Rise 1, run -2. Now I've created more points than you will need. If you just plot 4, -1, rise 1, run -2 to plot one additional point and then sketch your line, that's probably all that you need to do. Unless your assignment tells you to do something different. And I believe this will be our final question. So plot the point -3, 2. So left -3, 1, 2, 3, up 2. Slope, rise over run. We're going to rise 3 and run 4. Rise 3, 1, 2, 3, run 4. 1, 2, 3, 4. And any more points are going to take me off the graph. So I'm just going to stop there, and your line will look something like that.